Right, okay, hello Year 6 and welcome to another Science Mr. Robertson video. We've done our sledding labs and they've been really good. I have loved the creativity that everybody's been working on them with. In our lab sessions for the next few weeks, as we start our new topic of evolution, video on that next week, we can't really do a lab about evolution. So we've got to focus on finishing our projects and our posters instead in that time. It was a really good lab. We got loads of different experiments and I still am interested to see what the final results are. However, I want to remind us of the skills of how to do those conclusions and evaluations that could link in to this experiment. I'm going to give some hints in this video, so watch out and be on the lookout for those. Firstly, if I'm looking for those students that have A levels on their conclusions, they basically have well-developed understanding of how results could be different. Well-developed understanding of how results could be different. Basically, it falls into two different things you need to write about and discuss in a conclusion. One of those is, of course, the science of which is best. For example, if I had the group, I'll take the easy experiment. Does more people on a sled make the sled go faster? If I had results where the speed was getting faster and faster for more and more people on a sled, then maybe I could do some force diagrams that could explain why more people on my sled made it faster. That's really good. However, if I have my person on my sled and I measure the time here, will this time, will it be always the same? A good conclusion should also say how results could alter anyway. If I throw my pen up in the air, it's not going to fall in the same time. Could be because I put more force on it. Could be other things too. Could be a little gust of wind for more air resistance. Could be many different things. Could be the shape I have. Could be if I'm spinning it or not. Many different possible reasons. Again, even though you are trying to do it perfectly, trying to measure perfect, trying to go down the same, you don't. So what could have happened, and can you explain that a little bit? Important skill. That's the two things your conclusion should present. You should also make sure you are able to present an evaluation. The evaluation for the A wants you to suggest new ideas to make experiments better. Some of this you were doing when you were there. You were changing experiments because when you saw the hill and you saw how it's got to work, you had to change a few plans. It's important. However, you need to make sure you can show me what you would do if you did it again. I don't think we'll have time to go do it again. But if I told you and your group, right, you have to go out and do the same experiment again, tomorrow, but you have to make sure you can do it better. So your results are maybe more accurate, they are maybe more fair, and maybe more precise as well. Now, this is not just about, we can go and do it more times, or, we can use the same person on the sled. For the A level, I'm looking for some good, original thinking. Think about what the weather was like, or the conditions of the hill, how it maybe changed in the hour. Think about what your experiment was trying to find, and was it fair, or were other things happening that could maybe have changed more than one variable? The people were putting different numbers of people on the sled, were trying to change the weight, but were also changing air resistance. Is that fair? Is there a way you could do it to minimise it and make that risk smaller? It's food for thought, and it's not something that I'm able to help with directly, but I can certainly ask some questions and put you in the right direction. We're going to have, in theory, 2 more lessons, perhaps 3 if I'm really nice, where we're going to go and do the work on those posters. The rest of the time, we're going to go and work on evolution. So it's not much time to go and get these things written down on the poster, be able to present. Remember too, I'm looking to see your results in a clear graph. A results table as well, but it's a graph that's going to be far more important. Can you show me the data in a way that is clear to understand? And can you show me in a way that picks out the important bits of information? Do you understand what the numbers were you collected? And can you tell me why they're important? That's something I'm going to give more examples of in class time. For now, people, get your thinking caps on, and this week, come to that first lesson with one idea for a conclusion and evaluation from the experiment, so your group can start to finish your posters. Thank you very much.